Now that we've talked about ways of starting and stopping Java threads, and we've talked about ways of interrupting Java threads, let's talk about some patterns of handling Java thread interrupts in various ways with various side effects and various benefits and pros and cons. So if you recall here, blocking operations in Java can return automatically out of calls like sleep and wait and so on. And they'll return by having the interrupted exception thrown if the thread is interrupted. And we just talked about that when we talked about how to stop a Java thread using an interrupt. There are various patterns for handling interrupted exceptions in Java threads. And you can take a look at this link at the bottom of the slide to learn more about these patterns. Very useful things to know about. One way to do this is just to simply propagate the interrupted exception to the caller or callers by simply not catching it. So you'll see here in a second, what we're going to do is we're going to have a little example where we define the checked exception portion of a signature for a Java method, and we say this method throws interrupted exception. So for example, put and take on a blocking queue, throw interrupted exception. And that's listed in the method's so-called throw clause. And as you'll see here, put and take actually will not catch or handle the exception. They'll simply propagate it up to the caller. So it becomes the caller's problem or somebody else's problem, as they sometimes say. So you can see here that if we write code like this, we have ourselves a new string blocking queue. If we try to take an element from it, we have to wrap that up with a try-catch block or put the interrupted exception in that method's signature, and so on and so forth. So it now becomes the caller's responsibility to handle the exception properly. Another way to handle things is to perform task-specific cleanup before rethrowing the exception. So we might have a situation where if an exception occurs, if a computation is interrupted, then we're going to go ahead and essentially catch the exception, clean things up, and then rethrow the exception. So you can see here we rethrow the exception after we clean it up. Another thing to do is to restore the interrupted status after catching the interrupted exception. So here's a case where we're going to run some code, basically do blocking takes, and then run the computation after we get something out of the queue. If we're interrupted, then what we're going to do is do something or other, and then we're going to restore the interrupt flag saying, hey, we've been interrupted, so that this produces evidence that can be used by other parts of the program up the calling stack in order to react to the fact that an exception has occurred. And then yet another way of handling things, which is actually very bad, is to simply swallow the interrupt. So you can see here we're going to gaze, and then if an interrupt occurs, we're just going to swallow it and not propagate it. There's some times when this is useful. There's sometimes when it's not. We often do this when a thread calls sleep or join, and we don't really want to do anything when the exception occurs except just not propagate it at all. Now, as a general rule of thumb, library code that's meant to be used by other applications, so-called general purpose third-party library code, should rarely, if ever, swallow interrupt requests entirely. In fact, it's typically considered an anti-pattern if you do things like that. Instead, what you usually want to do, if you really don't want to do anything with the exception, at least restore the interrupt status after you catch it so that somebody up the call chain might handle it in some way. A good example of this is our acquire interruptibly method that we've been using for our semaphore implementations, where we restore the interrupt flag if it turns out that an interrupt occurs while we were in acquire uninterruptibly. Sorry, not interruptibly, acquire uninterruptibly. So we restore that flag so callers can know that we were in fact interrupted while we were waiting uninterruptibly. So that's a quick overview of some of the patterns of handling thread interrupts in Java. Invariably, you'll use one of these patterns in almost all code you write that involves interrupts.